In this module, we will study more about the interface that is used between electronic and optical transmission lines. Let us first look at the optical to electronic conversion. This can be achieved by using photoelectric cells. Light rays are shown on a photoelectric cell that in turn will generate the corresponding electrical signals. Now let us look at the second form of conversion, the first form being optical to electronic. The second form is electronic to optical conversion. In this case, we can send electronic signals into a device such as a laser or a light emitting diode, which is called LED or laser. When electronic signals are fed into either one of these two devices, it will generate the required light pulses to carry the information. Here is an example that shows the two devices that were discussed in the earlier case. One of the devices is the light source or the transmitter, where the electrical signal input is converted from electronic signals to optical signals. The optical signals then travel along the path of the fiber to the receiver. The receiver is known as a light detector. In this case, as we mentioned earlier, this could well be a photoelectric cell, in which case the electrical or electronic signals are converted back. The optical signals are then converted back into electronic or electrical signals. As mentioned earlier, the light source can be either a light emitting diode, that is an LED, or a laser diode. These devices convert incoming electrical signals into optical signals. Here is an example of electronic and optical interface. This device is known as the media filter or the converter. In this case, electronic signals that come into this side are converted into optical signals and transmitted over optical lines. One may note the fact that there are two connections in the case of optical signals. One is termed as TX for transmission and the other one is termed as RX for receiving. For information, on the left hand side is a local area network connection that is based on the 100 base T Ethernet network. On the right hand side is the fiber connection. These kind of connections are used for extending the distance between nodes in a local area network. In general, there is a limitation on the distance between the nodes when you connect the network under, for example, the 10 base T standard. Incidentally, the 100 base T standard. 100 base T stands for a Ethernet local area network based on the twisted pair wires and configured in a star configuration, and one that operates at a speed of 100 megabits per second. In the second example, we see a conversion again from electronic to optical signals, but in this case, on the left hand side is a local area network that operates under the 10 base T standard. 10 incidentally is the speed of the network that operates at 10 megabits per second. Base indicates that it's an Ethernet network, and T indicates that it uses the twisted pair wires. Here again, the fiber optic connection can be used for extending the distance between the nodes or the server and its clients. In general, as we mentioned earlier, there is a limitation on the distance between the nodes when we set up a local area network that is based on the 10 base T standard. Now let us look at some of the areas where fiber optics communication is used extensively. The number one application of fiber optics is to extend the distance between two points of communication. When we have electronic communication, there is usually a limitation between the points that are engaged in communication. For example, when we set up a local area network, there is a limitation of, say, 500 meters between two nodes of the local area network. By using fiber optics links, this limitation can be extended to several kilometers. The second area of application of fiber optics is in telecommunication. The long-distance cables or trunks are now laid with fiber optic cables. In other words, unlike in the previous case or previous era where electronic transmission was the norm in telecommunication with coaxial cables, now it is no more the case. Today, these long-distance cables are laid with fiber optic cables that have many optical fiber connections within a given cable diameter. The third major application for fiber optic communication is in setting up large backbones. An example is the setting up of a campus backbone that traverses the campus, connecting different computers together. Incidentally, there is a fiber optics ring that goes around the local campus, connecting various computers and networks around the campus. This particular campus backbone is known as the FDDI ring. FDDI stands for Fiber Distributed Data Interchange. The information in this case is carried along this fiber ring and exchanged between different computers that are located in different departments or administrative offices. Fiber optic links are also used extensively in internetworking. For example, let us consider internetworking in terms of connecting two networks. Here is network number 1 and here is network number 2. Assume that these two networks are connected to a switch, and also assume that this particular network is connected to a switch. In this particular case, it is possible, and it is often the case, that one may use an optical connection to connect these two switches together. This would facilitate high-speed transmission between these two switches and hence between these two set of local area networks. Here is a practical example showing the extension of the connection between two nodes using a fiber optics link. In this case, we have one network that terminates here, another network that terminates here, and the distance between these two networks have been extended by the use of fiber drivers. Fiber drivers are devices that are used for extending the connection between two nodes. In this case, we can extend the connection for 1.5 miles to operate at a speed of 256 kilobits per second, or we might extend the connection to 3 miles to operate at a speed of 64 kilobits per second. Incidentally, this is an older example, meaning that much higher speeds are now possible when nodes are extended over, for example, 1.5 miles. Here is yet another example that shows the extension of the connection between two nodes that are on an Ethernet backbone. This, incidentally, is an Ethernet network where the connection between this network and this network over here, which again is based on the Ethernet standard, can be extended up to 31 miles to operate at a speed from 56 to 2048 kilobits per second using a fiber optics connector. The device that is used in this case is known as the campus fiber driver. These drivers enable electronic signals to be converted into fiber optical signals and to be transmitted over longer length of transmission line. Now here is a picture showing the back panel of a fiber driver. In this case, we can see the two connectors. One is a TX connector and the other one is an RX connector. Here is a connection for a data terminal device, meaning that In order for us to program this device, we will connect a terminal to this device and program this device to operate in the manner desired.